Okay, so SNIA, you have a Smart Data Accelerator Interface, or SDXI, technical working group, and I believe it was set up to address the current issues around memory-to-memory data movement. So I guess just a little bit of background on we'll flesh out what that actually means.
Yeah, if you look at software stack today, our current data movement standard is a software mem copy. This is because a software mem copy enjoys a very stable instruction set architecture with CPUs. But software mem copies take away from application performance. So if you look very closely, multiple layers of software perform mem copies just for doing things like context isolation. And these layers exist for various use cases like virtualization, having containers, or just for creating separation between user and kernel software. And most devices today, even if they're I/O devices, they perform DMA for things like network or storage I/O. They don't perform a memory-to-memory DMA. And while memory-to-memory DMA acceleration has existed, it has been based on proprietary vendor implementations with no standardization between vendors. So something else we want to consider here is like we need an accelerator interface that is one form factor independent or implementation agnostic. So just like traditional compute devices like CPU, memory data movement and acceleration is equally important to other kinds of compute accelerators like GPUs, FPGAs, even computational drives, and other terms that people like to throw around like DPUs, XPUs, and IPUs. And memory is no longer limited to traditional and proprietary DRAM-based interfaces. It is now possible to access memory via interconnects like CXL, which is another standard that is brewing in the industry. So you can also have memory with different kinds of properties like persistence, or it could exist in device memory as MMIO. So in whole, memory tiering with different classes of memory and interconnect type is needed. These different usage models and environments need a holistic standards-based approach to future-proof applications that will take advantage of this acceleration.
Okay, so you've explained quite a complex landscape, but your simple, in inverted commas, objective is to create a standard data mover interface. So I guess what does that involve? Bearing in mind what you already outlined is quite a lot of different things going on.
Yeah, absolutely. So Smart Data Acceleration Interface, or SDXI, is creating the industry's first standard for a memory-to-memory data movement and acceleration interface that is extensible, forward compatible, and independent of I/O interconnect technology. That would be your short tagline.
Okay, yeah. And in terms of the actual practicalities of that, I guess of what you described earlier, you're going to try and support a number of what you would deem sort of desired data movement characteristics or attributes. So you're going to try and define what's must-haves, and I guess, as you say, open to all before anyone sort of adds any other layers. Is that correct?
That's right. So among different things, SDXI is envisioned and designed to support data movement between different address spaces. So this is address spaces, which includes user address spaces or address spaces in different virtual machines. And to be fair, data movement should occur without mediation by privileged software. So if an application wants to do the data movement, it shouldn't have to transition into kernel software just to be able to move the data. Of course, once the connection has been blessed or it has been established, you can make that happen. But it kind of has that separation of user and kernel that is needed, but not when the actual data movement is happening. You need to allow abstraction or virtualization by privileged software. And something that is key that we are designing into is the capability to sort of quiesce or suspend or resume an architectural state of this data mover. And why is that important? If you ask me, that it's because we want to enable live workload migration, or some folks call it machine migration between different kind of servers. So the ability to be able to stop, suspend, and resume is important for those. And compatibility is very important. So that's what we're trying to design here as attributes, is to enable forward and backward compatibility, so that now you can build interoperable software and hardware. Something else that I want to highlight here is when we build a standard like this, we can incorporate additional offloads that leverage the same architectural interface. And overall, the DMA model is meant to be concurrent, which means multiple DMA accesses can happen at the same time when one is not getting the other.
Okay, and in terms of the inspiration or the seed for this, did you as an association identify the problem and then sort of start up the technical working group, get people to join, or did various vendors come to you and say, look, this is a bit of a Wild West scenario and we need some kind of, formalization around a standard to help us all move forward? So where did the impetus come from?
Yeah, absolutely. So this TWIG was, or the technical working group that we call, was formed in July of 2020. And it started as a specification that was contributed by Dell, VMware, and AMD. Since it got formed inside SNIA, the technical working group has grown steadily to almost 28, 30 member companies, and almost 80 plus members being part of this technical working group. Many members have contributed in sort of various ways towards improving this specification since its initial contribution by the founding members. And kind of their contributions have resulted in improvements in many areas, like defining an architectural behavior of the start-stop operations, architectural context states, and architectural states of the function and SDXI function implementation, improving things like how does cache placement work, or cache injection needs to work, having a discovery of different groups of SDXI function implementations, error reporting. I mean, I can list a whole bunch of things, but something that very critical that we did was the language of the specification is very interconnect agnostic. So you could take any interconnect and still be able to implement SDXI with that, say PXCIe or CXL, or maybe, I don't know, someone else has a proprietary interconnect, they can still implement a standard SDXI implementation with this.
Okay, so the work has been going on the specification for about, I guess, a couple of years. And what else is there needed to do? Because I presume you're working towards creating and ratifying some kind of a standard. So what's the roadmap for that look like? Absolutely.
So since we started in July 2020, last year in September 21, we released our first public draft that went through about 8 months of public review. We just released a candidate for 1.0 in September this year, which is expected to become the 1.0 standard before the end of the year. So along with the draft specification, we also included header files that are auto-generated from the specification, so that implementations can start using these standard structures and begin their implementation. In terms of ratifying an initial standard, we're currently in that 60-day membership and public review period, which means once that finishes before the end of the year, we would incorporate any review feedback that comes in, and that will become the 1.0 standard and 1.0 SNIA standard. to be precise. And after 1.0, we kind of plan to work on future versions of the specification to incorporate additional features.
Okay, so there's quite a roadmap there. In terms of opportunities, I mean, if there are people, it sounds like you've got a pretty big sort of community already, but I mean, are there opportunities for other storage vendors, I don't know, end users, whatever, to get involved, or is it pretty much you've got everyone you need, or where are you at?
No, it takes a village to build, right? Absolutely. As we bring activities around version 1.0 to a conclusion, we are also ramping activities in compliant software implementations. So common software stacks and structures across all OS implementations are being discussed within the TWIG and being proposed. So participating in these discussions or code contributions can ensure you're ready to take advantage of them in your applications. So already some chip vendors are participating actively in the TWIG. So if you are a chip vendor looking to develop SDXI compliant implementation, you may want to join the TWIG to ensure you are in compliance. Reading a spec and implementing is certainly possible, but you might want to come in and make sure your interpretation is good. You may also want to make sure that the next revision of the standard, which will include more features that we are going to work on, meets the technical requirements of your company. And for any reason, if you cannot join the TWIG, you may also provide feedback using SNIA's feedback portal. But I would say, if you're interested, and actually this makes a lot of sense, joining the TWIG is the best possible way to start getting into it. It's a fun group. It's a lot of members in it, a lot of very senior people with a lot of expertise in it. So I would definitely ask people to join.
Okay, and in terms of so on the developer side, I'm just thinking for the end user. So if I'm a storage user in an enterprise, whatever shape or size, what will this standard mean? I mean, will I notice anything, or is it all under the covers? So life will just go on merrily as it always has, or will there be sort of certain benefits or characteristics of my storage that I'll notice? Go, hey, that works better, or faster, whatever it is. Yeah, how do the end user find out, notice what's going on, I guess?
Well, thank you. This is a very important question. This work is a framework to unlock innovation from various acceleration vendors and make it available to sort of various software stacks. By leveraging a memory-to-memory data movement standard, vendors can innovate around the specification and offer many different types of accelerators, directly benefiting the applications. Because remember, we are not making the applications go through layers of stack just to be able to use the accelerator interface. This includes storage applications and non-storage applications. So it includes applications that run bare metal or they run virtualized. They could be used by kernel mode software or user level software. So many network and storage stacks already perform multiple buffer copies. SDXI assisted network and storage implementations can eliminate or accelerate many such redundant and unoptimized software memory buffer copies. There are also some use cases we are envisioning for virtualized environments, which are very specific to them. Like, for example, the spec is fulfilling the need for when virtualized servers want pre-filled large memory buffers. Filling them with 0 is a necessary an important step for security. You don't want your data getting leaked when you're spinning up and spinning down VMs. SDXI provides an interface that accelerates even these kind of memory operations. That's what I meant, that different kinds of applications may use this. Also, many operations that involve inline data transformation of the data as it moves from, say, a source location to a destination location can get accelerated. So for example, these data transformations could be compression, encryption, or other kinds of offloads that involve data movement from one location in memory to another location in memory. Let me also kind of take you to a thought exercise, right? If you have a system that has different tiers of memory, like DRAM memory, or memory which is persistent, a memory that is behind like a device, or if the memory is far across a memory fabric like link, CXL or a link, then SDXI is being designed to target all such memory address spaces to accelerate data movement. And as various software stacks and storage stacks begin to embrace CXL, SDXI will become an important standard that implementers need to consider.
Okay, and just quickly on the time, you've told us obviously that you're hoping the standard will be 1.0 will be ratified by, I think, by the end of the year. But in terms of the vendors bringing out solutions, I mean, I imagine some of them are already, obviously if they're working on the standard, they pretty much know what it's going to be, hopefully. So they're working. I mean, will it be soon in 2023 that SDXI compliant solutions, or will people have to wait maybe to the second half of next year? What's that sort of time frame?
Yeah, no, it's a good question. I think a lot of the, I guess the vendors are thinking about the implementations, and some of them are further ahead and some are still working towards it. But it would be a safe bet to think that 2023 would be the year you might start seeing implementations.
Okay, well, it's been lovely to chat to you, and a great new technology solution, whatever. So be interested to see how it develops. We can maybe catch up again, but for now, Shyam, thank you very much for your time. Thank you.
Thank you, Philip. It was great chatting with you, and thank you for spreading the word.
Thanks again.